Hello and welcome to this second monitoring and maintenance lecture in this course, Mastering Artificial Intelligence. So in this lecture, we will talk about how to use three things: statistical tests, visualization techniques, and drift detection algorithms to identify data drifts, right? So, question for you now is how to use these three things: statistical tests, visualization techniques, and drift detection algorithm to identify data drifts. Any thoughts? See, identifying data drifts requires you to compare the distribution of the incoming data, that is the recent coming data, with the historical data. And basically what you do there is you detect significant changes or deviations in the data. Now, how can you do this comparison and detection using statistical tests, visualization techniques, and algorithms? Let's take a look at that. So, first thing is to use is the statistical test is what is called a KS test, Kolmogorov-Smirnov test. Little tongue twister for me, but let's call it a KS test. Now, what does this test do? This test compares the cumulative distribution function of two samples and computes a statistics that you see here uh, that represent the maximum difference represented here by the red arrow between the two CDFs. A significant difference suggests a shifted distribution data. And for significance, you can use very large number of significance tests like t-test, z-test, etc., etc. The second test that you can use in statistical test is the KL divergence test. Now, what does the KL divergence test do? It measures the difference between the two probability functions of the two sets of data, and it can be used to quantify the discrepancy between the distribution of incoming data and the historical data. Then there are visualization techniques, and let's start first with the simplest of them is histogram. Very powerful technique. You can plot histograms of key features or variables in the incoming data and compare with the histogram of the historical data. A visual difference in the shape, as you see here, spread or peak, more so here the peak of the histograms may indicate a data drift. So that's one of the ways to use the to figure out the data. Second technique is to use what is called in visualization techniques is to do what is called density plots. You visualize the probability density function PDF of the data distribution and compare them over a period of time. The difference in the shape or location of the peak suggests again distribution data drift, data drift of the distribution of data. Then there are scatter plots. And you can create scatter plots as you see here to visualize relationship between two pairs of variables and detect changes in the patterns or correlation between the two features here. You see here a different type of data and the red versus the blue, you see a clear difference in the data distribution. Then you can use the algorithms, right? You can and one of the algorithms to use for data detection is to use the drift detection trees. Now you can construct decision trees or models using historical data as training data and use them to predict outcomes and labels of the incoming data. And there you monitor changes in the prediction data or error rates, and if there are higher or different error rates in the prediction accuracy, there is clearly a data drift that you need to check out, and it kind of detects the data drift. Also, you can use an algorithm in which you can use the change point detection. So apply the change point detection algorithms such as QSUM, cumulative sum, or exponentially weighted average (EWMA) to identify abrupt shifts or gradual changes in the data distribution. I would suggest you come back and read this by downloading the PDF file. I am not going to explain what is written here, what you can read out yourself. Then there is, you can use density-based drift detection algorithms such as DB-scan or Gaussian mixture model to cluster incoming data and compare the cluster assignment with historical data. So you see here in this different databases that the clustering is quite different between the two data sets, and it says there is a drift in the data. So changes in cluster centroid or density could indicate data drifts. Then you can do what is called feature drift monitoring, focus on monitoring specific features or variables that are critical for the model. And in that, what you need to do is to track statistics such as mean, standard deviation, skewness, kurtosis, and of the feature distribution over feature distributions over period of time, and detect the significant deviations from historical values. Similarly, after having detected the data drift, what you need to do is to define thresholds or tolerance level for statistical measure of or drift detection measures. A tongue twister for me again, based on the domain knowledge or business requirements. So set thresholds or tolerance. Till what time would you say it is okay? Then you trigger alerts or notification when data drift exceeds this predefined thresholds, indicating need for further investigation or action. So you need to define these thresholds and then set up alerts accordingly. So by combining these statistical tests, visualization techniques, and drift detection algorithms, you can effectively detect the data drift and take timely corrective action to maintain the reliability and accuracy of your machine learning model that is deployed in the production environment, right? So what is next? So another kind of drift that can happen is in the model itself. So in the next one, we will talk about how can you detect this model drift. And there is three things we will talk about: concept drift detection, anomaly detection, and ensemble monitoring. So thank you so much for watching this second monitoring and maintenance lecture. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download a PDF file to take a look at anything that you need to do.